welcome to another office hour, JSON office hour session on bringing SQL to MongoDB API, whatever this means really. Okay, let's get started. So we have Herman here and Josh, and my name is Beda, and we will give you like a little introduction to a new capability we added, and it's going to be some concept slides as well as a demo. So maybe let's go to the next slide. So little
Yep, I'm on my way. It's just quickly to chime in here. I put the safe harbor statement in just, to be legally correct because some of the functionality that we are talking about will be available through ORDS 24, which is supposed to be imminent, but I checked it's not available for download for you guys yet, right? But everything is there at a fingertip. So we hope that by the time we're done today, you might be able to try all these things out yourself. Okay, Peter. Back to
Yeah,
you.
and while we talk here, please put your questions in the Q&A or in the chat. There's already a question like, is this recorded and where can they see it later? Yes, it will be recorded and you will see it on the Ask Tom Office Hours site as well as on YouTube. So I'll tweet a link once this is uploaded, probably in 2-3 days it will be available. So yeah, big picture, before we do a deep dive into the feature details, let's look at the big picture here. So our main mission is to enrich Oracle database to solve all your data processing needs. So we don't want people to have to run many different databases like often people use what's called like best of breed. They use a relational database for some operations. They use a graph database for something else. They use a JSON database. And at the end, they have like 3, 4, 5 databases. And then they realize that for many use cases, they actually need to query multiple data sources. Let's say they need to join relational with JSON, or they have some JSON with spatial contents. And then they start moving data around in these different databases, issue one query here, issue another query there, data gets inconsistent or data gets stale. And then they end up with like a very expensive to maintain piece of architecture that doesn't even satisfy their requirements, where queries take long, etc., and where operational aspects like a backup or a point-in-time recovery become very hard or even impossible. So this is the picture on the right with all these little arrows that you have to maintain. And we think it's much simpler if you use a multi-model database or converged database. This is what Oracle has. So we have capabilities, obviously, for tables and columns. We have capabilities for spatial, for graph, for XML, and full text, and also JSON. So we're focusing on the JSON part here. And the benefit of this model is that you have the same transaction, you have the same SQL, you have the same security model. So it's from an operational standpoint, a huge simplification if you run all your use cases against one database. Next slide, please. Right, and now if we look at the JSON component of the converged database, you may have seen this slide. We've shown it many, many times. And the message is if you store your data, this is the diamond in Oracle database, we allow you to access this data as rows and columns using SQL. This is the right side of the slide, as well as as documents. So depending on the role that a person has, they want to interact with the data in different ways. So an application developer may say, hey, I'm really interacting with my data as application objects. I have something like a purchase order or a customer, etc. And I prefer to use a simple NoSQL style API where I can do simple puts and gets or finds. And I don't want to be bothered with writing like complex SQL to do a bunch of joins. So these JSON document APIs are much simpler. While at the same time, if you have a report or some analytical queries, it would be a lot easier if you can write SQL against it. And we provide you all these capabilities. We have document APIs, MongoDB compatible. So there's SODA, there's the MongoDB API, there's REST on the left side, and on the right side, there is SQL with JSON enhancement. So there's the JSON table, JSON value, JSON query, etc. Not only did we invent these operators, we also contributed those to the standard. So now you see Postgres, I think with a 10-year delay, finally announced they will also have JSON table, which we added in 2014. Good. So what does it mean? Next slide. It really means you can access the very same data using, or you can view the very same data as JSON collection. So here you see movies, insert one. This is like a NoSQL doc store API call directly from your application code, like Java or JavaScript. Or you can access the very same data using SQL JSON, using standard SQL statements. So again, this is just a recap. Depending on your role or on your preference, you can access the data the way you want. So what is new here?
Okay, yeah, let me take over, right? So what you have seen so far, what Beta was talking about, this is really the classical vision and picture of how Oracle sees you working with your data, that you use really the API to work with the same set of data whenever you need it. But what we're doing now with this new functionality, it's not only a whenever you need it, but also a wherever you need it. Because if I were to high up level what the functionality is that we're talking about now, we're basically making SQL available through the Mongo API, as you see in the box that appeared on the slide, right? So you're using the Mongo APIs, the Mongo interfaces, SDKs, and you use the $SQL operator to pass SQL through the Mongo world directly to the Oracle database. It is basically, now the question is, okay, before we go there is, one of you might ask, okay, why are you doing this, right? That's a good question. That's a good question for Mongo as well, because when you look at it, Mongo is actually trying to do that. It's not fully clear to us what they're after here. Hunch is that they will try to probably venture down in the world of making their stack available to tools that speak JDBC, but it's a long ways to go for them, right? Because, well, Mongo doesn't speak SQL, and as of today, the SQL operator in Mongo is in beta stage. And what you see on Atlas, it's all read-only support, so they're really starting to walk at this point in time. Whereas, right, when you think about Oracle and you think about SQL, you kind of say, I think Oracle does this for a long time. So, and this is actually what we just introduced here, the capability of really using a MongoDB API for an application and pass the SQL through to the database. When we step back for a second, the way of how the Mongo API works, the Mongo API is kind of a driver that is part of the Oracle REST data services, where a MongoDB application speaks to that driver Mongo language, right? So the Mongo application that you see on the right-hand side speaks Mongo and doesn't know that it does not talk to a Mongo database. And the Mongo API basically translates this verbatim into SQL and speaks to the Oracle database through SQLnet. So the Oracle database then sees only SQL and doesn't know that actually the request wasn't coming from a traditional SQLnet client. And with this new functionality, we have this SQL pass-through where you can pass statements and data, that is very important, back and forth between these two different worlds, completely transparency. So now, before I'm going into a demo, let's quickly introduce the $SQL operator and what we're doing here. And at that point in time, a kind of a warning. So I'm dealing with the relational world for a couple of days, as you might see with my gray hair. So what my colleagues like Beta and Josh are teasing me all the time on is that whenever I try to say $SQL, I wouldn't say it's 9 out of 10 times, but it's definitely measurable. I will say $SQL. So whenever I'm going to say $SQL,
I said, good.
yeah, I mean actually $SQL in that context, right? So it's $SQL.
I will blow a horn whenever
Okay,
you
yeah.
$SQL.
As
No, I'm
you
kidding.
promised, he threatened me yesterday to bring his vuvuzela and make some big noise whenever I say that. So $SQL is the stage operator that we're integrating here. And let's quickly step through the syntax of what it means. The syntax is strongly aligned with the syntax of the operator in the Mongo API. So you see the syntax for the $SQL operator has four four keys that you're going to put in, right? The first one is obviously the statement, right? That specifies the SQL or the PL SQL that you want to execute in this pass-through mode. You have the capability to pass bind variables back and forth, right? The binds, I will talk a little bit more about them, are obviously optional, right? If you just do a plain data retrieval that is encapsulated, you don't need binds. And you can specify the binds, positional or named, and with additional attributes like the data type, right? There is two additional keys, fields that can be put in the Mongo framework, a format and a dialect, right? From an Oracle perspective, for our operator, both of these variables are optional, and at this point in time, the only supported value for both of those is Oracle, right? So you can specify them or not. It's there at that point in time for the operator compatibility, and we will see where the world will bring us with that. We also introduced a simplified form of this operator where you basically just specify $SQL and the SQL statement that you're after. Now to the binds. The binds have obviously some input parameters. It can be up to 3 values. The first one is you specify either an index or a name, which is index would be a number, name would be a string variable, where you define whether you do a binding positionally or whether you bind based on a name, as you see on the right-hand side. So the right-hand side has the same insert statement, one time with the name notation on the top, where I'm naming the bind variables and assign the values to those. And then the second one, the positional variation, right? The value obviously is the value of the bind variable, and you can optionally specify the data type of the SQL bind type if the default mapping based on the BSON type is not sufficient for you or not specified. Okay, so the bind variables, there is a couple of ways of how we can actually leverage the bind. So we introduced different variations of syntax, to cope with different programming paradigms and to make it also, when you look at the lower left corner, as simple as possible for a code generation. It's also when you use the aggregation with binds, you can do single execution as well as multi-execution of a statement. So let's step through the 4 cases briefly. So the case 1 on the upper left-hand side is using the bind notation where the binds are passed as an array containing objects. That is also what you have seen on the slide before. You see the binds variables are in that case 2 objects that specify the named usage of my empno and my name with the values that are assigned to it. If you have such a simple case where you have the values and the bind mapping with the data types is clear, you can switch over to using the array of primitive values, what you see in the lower left corner, where we passing in, where the bind variables :1 and :2, which are just positionally bound with the array of primitive values. So you see, going from case 1 to case 2, right, we save ourselves naming bind variables or specifying the index, what they do. We're just passing in the array, and in that case, E123 will be bound to :1 and John Doe to :2. In that case, obviously, well, if you were to switch the bind variables, you insert the values in the wrong order. The third alternative is that you just pass the values as an object, where you basically skip the notation or the verbose form as we have seen it in case 1, and you just say, okay, bind variable empno gets E123 and bind variable ename gets John Doe. That could be also position 1 gets E123 and ename gets John Doe. Now the fourth variant in the lower right corner shows you how you can use that for multi-execution, right? So what you're seeing here is, and the syntax is an variation of case 1, 2, and 3, where you're passing in a bind of any of the case permutations of 1, 2, or 3 to execute it multiple times. So you see when you compare case 2 on the lower left corner with case 4, so to speak, on the lower right corner, you see that the array of primitive values is now a nested array within an array of bind variables, meaning that when we compare all of those, case 1, 2, and 3 are actually passing in one bind, whereas the multi-execution case with an array of one of the other cases is passing in two bind variables. So this statement will be executed twice. So now, how and where do I specify the dollar stage? Okay, so
Hey, can I just one second,
absolutely.
if I may interject, if you go back to the
Absolutely.
previous slide,
Okay.
just to explain why binds are useful. You could obviously inject the values themselves into the statement, like without this colon myAmpNo, that would obviously work. But then if you change the value, every query would be different and would be recompiled. So what the use of these bind values gives you is that the query is faster in execution because we take one that was previously compiled and only replace the bind values. So this gives you, this is the general use of bind variables. I guess most database people know it, but not every programmer knows this actually. So often they just do string concatenation to do to build the SQL string, which is a bad idea anyways, because that opens it to SQL injection. So yeah.
Yeah. Thanks, Beta.
Yeah.
Okay, now let's talk about this dollar SQL stage, where and how we are actually going to use it. So you can use this stage operator on a database as well as on a collection level, like you see in the upper left corner, where you see you can specify it within a database as db.aggregate and then specify your SQL stage, or you can actually tie it directly to a specific collection where obviously the context then is coming from the application or potentially from the collection, or potentially stages that are prior to the $SQL operator. The $SQL operator supports all types of SQL operations. That is, selects, DMLs, DDLs, as well as PL SQL, and as we talked about a little bit, it supports bind variables. So where's the difference between the single stage or embedded into multiple stages, or the db.aggregate versus db movies aggregate? If you're embedding the $SQL operator into a multi-stage aggregation, only select statements are allowed, and the select statements must return a JSON object. This is just the nature of the aggregation pipeline framework of Mongo. For those of you that are familiar with that framework, the framework is kind of for people that come more from a SQL world, you can understand this as defining various stages of a SQL statement. Like when we look in the second case, and we will see that live later on, the various stages is you're working on a collection movies, and the first operator in your pipeline is to match it, to basically filter the records. Before then, with the new operator, you would actually enrich the data or join the data with something else, or apply some procedural business logic coming out of the database, and then you would apply another stage. In that case, you're only limited to the top 10. So when you embed it into a flow like these 3 steps, right, the $SQL is really a data pipeline which takes data as an input and produces data as an output. From a transactional consistency, well, it's the Oracle database. If you use Mongo without any transactional boundaries, well, everything is auto-commit. But if you use a Mongo-driven transaction framework where you start a transaction and end a transaction, you're getting the full asset protection of the database where changes will only be seen after they're committed. So I talked about using the SQL select in a data flow. And what you're seeing here is the most simple example, right? It's a data flow. That's a database level operator that you see here that I'm executing, where the SQL statement is just selecting the sys timestamp and the banner from the $v version table in Oracle and returns this as a JSON object, right? So this data is now readily available in your Mongo application. If you're doing the embedding of the SQL operator in a multi-stage aggregation pipeline, like I briefly talked about before, you actually controlling the data flow between your Mongo world, the Mongo collections, and the database operators. So what you see here is I'm working on the movies data set, and I want to match just a specific genre, basically a filter condition on all my collections that I'm having. The data of this stage of the dollar match stage is now available as basically quote unquote a relational view inside the database with the name input that generates a specific single JSON data type column. So this is functionality that is only available in Oracle Database 23. When you try that today, so Autonomous Database supports the $SQL operator, and we will come to the limitations between version 19C in general and 23C in a second. This statement would not run. It would give you a nice compilation error. This works in 23C. But to continue that, right, it's what we are basically now doing with this embedded $SQL. We are taking the filtered data set from movies as input I, and we can operate on the JSON collections, the JSON documents, through the relational specification of the column data and do additional operations on specific attributes. So now you're bridging the world coming from the Mongo world and using the JSON operator framework that is available in the relational database. You see there's further steps, right? We're projecting only a couple of columns that we want to do, and we're going to do a sorting. And what you would get back in that case is, the protection of the columns that I'm looking after with the operation that has happened in the database. And when you look closer, what we did actually with this specific simple example, we applied a JSON merge patch, which is in that case a data enrichment operation where we add an additional attribute called leap year that actually calls a PL SQL function within the database. So this is how we say it's now the paradigm is not only you're using the language whenever you want it, but you use it wherever you want it, right? So if this leap year would be a business function that is actually ingrained in your overall data management architecture and used to enforce or apply some business logic or business rules that are relevant for your business, you can just now readily use them from within, the Mongo API. To quickly talk about it, since this is a framework, right, it gives you an input and an output. What are the return sets of these operations? We talked about the select statement, which returns you a JSON object or a collection of JSON objects, as we have seen on the slide before. So now what about the other cases, DML, DDL, and PL SQL? So the return set is a single object or array of objects that defines the results equals to the number of rows that were changed, if that is known, right? Like you see on the left-hand side for DML, the two cases of an insert statement with a multi-binds, the result will be 1, 1, which means, okay, that statement was executed twice. If I do a deletion from a table, At that case, we know the number of records that were deleted. The result is the number of records that were deleted. Similar to a DDL operation, if you create a table, a create table, a select, the number of rows at that point in time is known is returned. If you create an index or you drop a table, right, the result will be null because at that point in time, it's not known to the aggregation framework or to the SQL operator, okay, how many rows you dealt with. And last but not least, if you do a PL SQL operation, it's just a procedural block that is executed that isn't necessarily tied to any number of rows, like you see in this very simple example. If I do a sleep, well, there's no rows that are impacted in any way, shape, or form. Okay, so why did we build this, right? We really built this not just because Mongo has it or Mongo tries to build it. There's actually use cases that we got from our customer base, where there was a definite ask for this functionality. And there is basically three, I try to, up-level it. There's three big themes and categories of use cases that we were asked for, right? The first one is access to relational data. You just happen to, if you're not only living in the world where documents are everything, right? Chances are that there's other data that is relevant for an application, or that might become relevant for an application, or that might be beneficial for an application that deals with documents just to be readily accessible, right? And with this pass-through, you have the capabilities just to reach out into the database, to select any arbitrary result set, and expose it as a collection within your application, right? So now it's really the sky becomes the limit, and whatever data and whatever functionality you have in the database from a processing perspective in the SQL framework becomes accessible and visible for the document world. Which brings us to the second bucket. It's the relational processing. There are some capabilities that are either only available in the computational and processing framework of the SQL language with all the other embedded converged functionalities, whether it's spatial, graph, machine learning, or just the analytical capabilities that you have in a database, right? With the pass-through, it's not only a select from a table and present it as an object. It can be a very complex relational processing that you, so to speak, outsource to the database for processing and have the exposure as a document. And last but not least, it's a very important framework for us and our customers to bridge the gaps, right? It is not Oracle's intention with the MongoDB API to be a me too and trying to be a better pure document store. That's not the intention, right? They will develop something new and we're going to do the catch up and we're going to build it, right? This is where you bridge the gaps. But the big thing here is that you can use that framework to actually do that and enrich it with the other two things that are not available in a pure document store, right? So it's the pragmatic approach. Just to give you an example, in the autonomous database today or an Oracle 19c database today, our Mongo API does not support the Mongo API lingo to create indexes, right? With the $SQL functionality, we very simply and easily bridge the gap and enable you to create indexes without ever leaving the Mongo realms and the Mongo framework, right? Prior to this operator, you had to start a SQLnet connection or to go to the web interface in SQL Developer Web to create an index through that. There was a little bit of a hassle, right? Yes, you still have to use the Oracle syntax here until Oracle Database 23, but you're never leaving the realms of your Mongo API and development environment. And I think I have spoken a little bit enough, so now let's just try to show you a little bit of what we're doing here. So I'm now here in Visual Code. I hope the font is big enough for you folks. If it's not big enough, or if it's too big, just throw something on Q&A and let me know, right? So I'm connected here to let's just go to the Mongo world first, right? I'm connected to an Oracle database through the Mongo API to the database JSON, right? And the database JSON has this one collection movie, right? You would also see it right here. Okay, show collection movies. Okay, so now this is an Oracle database. Let's quickly use our first pass-through operation where we just want to see, okay, what time do we have right now and what database are we actually connected to? Okay, you see that's our UTC timestamp, and we are connected in that case to a 23C database, right? I picked a 23C database for the purpose of the examples because that has the full functionality set. Statements like this would obviously work very easily with the autonomous database or 19C environment today, right? If you wanna have the proof that it's actually the same database, we could do actually the same statement in the Oracle database, right? You see it's the 23C. I could go to database name, and it's pretty close to what we're having there as well. Okay. So now let's just step a little bit through some of the functionalities that we talked about, right? The first one is, you can do a very simple join and aggregation in the SQL world and expose that as a JSON document. So you see, I'm actually picking here the SH schema that it is readily, executable for you within any autonomous database where the sample schema is pre-installed or where you can install it in an unmanaged database through the sample schemas that are available on GitHub. And you see here, I did an aggregation, a join, and I get the result returned as a JSON object. Now, let's look at the statement, and now I envision this being embedded in an application where the application controls the input, right? Where, from a context-driven perspective, you don't necessarily want to see all the data. So we only want to see the data for the year 2019, right? And now you see I'm using the bind notation, the positional index notation, where I specify an object with the with the index value. And you see now all of a sudden the result is actually limited to the year 2019. I could use the going from the index notation over to the named notation. You now see that instead of having an index 1, I have a named bind variable, my year. And I'm not only specifying the value, but I'm specifying an explicit bind of the data type for that statement. And you will see when I'm running that, you will actually not see any difference on the screen because the result set here is exactly the same. Last but not least, to show you the simple variation of the bind variables, that would be how it looks like, right? If you just say, okay, I want to have a positional bind, and I'm just giving you an array of primitive values, and voila, as expected, the results are the same. Now, this is very, very, very simple way of exposing purely relational data in the Mongo world, but there's more to it, right? Now, when we talk about data enrichment, what about trying to combine data that lives in collections with data that only lives in a relational world? And for those of you that know Oracle, will now hopefully get a smile on their face. For those of you who don't know Oracle that much at that point in time, let me introduce one of the most famous sample schemas in the Oracle world, which is the so-called emp and depth schema, which was actually introduced in the very early initial days of Oracle and which are still around, which is a very simple relational model, a two-table model with a primary key, foreign key relationship between employees and departments. I installed it in the database, and now I'm going to JSON-alize, one of these tables, the emp table. So what I did here right now is I basically just took the table emp. We can quickly do it. Select star emp. Okay, let's just quickly do this here. A pure relational table you see with emp no, ename, job, manager, and all this kind of information, and JSON-alized it, so to speak, right? So if I were to do db dot, how did I call it? Emp, I see emp JSON find. You will actually see the same information that you see relationally now as a JSON collection in your Mongo world, right? So it's really a persistent collection. If I were to look here, let's just do select star from user tables. You will see here that we have the table emp JSON, which is the physical container for your collection in the Oracle database. And now let's take this as an example. Okay, no, we don't want to drop it. And actually join this information in my emp table, in my JSON collection, with information that comes out of a table called dept, which is the primary key, basically the table with single entries for the departments. And what I'm doing here is, let's just see what I can quickly, where's the line to move it? Here, to make it a little bigger, right? I'm using a JSON transform operator and set a new variable department name, dname, and I remove the depno information here in my object, and replace this basically with the department name. So when you see here depno, I replace this with the department name. So I'm joining here really a purely relational table with a Mongo collection transparently. And this is really how you can easily combine the functionality of the pure relational world with the Mongo world, or very, very similar to what we did before. I had a function leap year on the slides for you. I can actually show that live to you. So I'm now using the aggregation function to create a function leap year in my Oracle database. So that represents the business logic that is used in both the relational world for my relational applications and for the Mongo world to provide business continuity. And now I'm doing the statement what I had on the slide, where I'm enriching my data with, what did it do? Okay, let me just see. This is the way of how you see that it's live. Let me just quickly do that again. Where did I have my leap year? Did I have something in there? Yeah, okay. Yep. Obviously, right, if you're specifying things wrongly, they're not supposed to work. Okay. Try it again, all good. Here we go, right? So as you can see, it's live and it's really doing something in the Oracle database, right? So you see the new information leap year was generated, the business logic was generated on the fly. Now, quickly changing context a little bit, right? It's when you come from the document store world, we always have this notation or this application paradigm that, okay, you should model your objects, your documents along the lines of how an application is using it, right? And when I look at this one here right now, it's driven by movies as an entity, right? For a specific movie document, all the derived attributes are stored and all the derived information is nested, right? Basically, the primary key, foreign key relationship is implemented in that way, right? You have an array of thru, you have an array of actors, you have all the information that is actually relevant is basically built hierarchical underneath the tree of my movies document, right? But now what is it if your application all of a sudden would be interested in actually seeing the world slightly different, right? Like what would it be if all of a sudden the actors are the driving force? And I want to quickly show you how you could easily do this, right? So this is a statement. So let's quickly break it down. I'm basically using SQL functionality. Okay, I should have probably made that a little bit more. Can I actually, let's just see. Now I'm really going down. Ooh, look at that. Down and explain the thing. So I'm using SQL operations to access the storage container that contains my collection. And I'm basically unnesting the information of the actors and preserve the year, the revenue of the movies, because my business case for this is I want to see how successful are movies actors overall. I'm not interested in the movies, but I want to see how much is a specific actor contributing to the revenue and how many movies did the actor actually appear in, right? And now you see is coming from the original model of, okay, there's a movie and there's somewhere, you have hidden the actors in there. Now, all of a sudden, you pivoted the information and your document, the driving force is the actor, and you could have an array under there to actually store the movies as well. So now, with that operation, right, okay, we have done it in SQL. So now I'm actually just want to do that in my Mongo world, and I'm not only want to pivot it, I want to instantiate it, right? So you see here it's the same SQL statement, which pivots the information with the nested data. Let's just execute that. And what I'm also doing is, you see, I'm creating a new collection, movie actors, right? So I did that. And if you're now doing a movie actors find, you will see the information that we have seen before being made persistent as a new collection. If just by reaching out, running a SQL statement and embedding this in our aggregation pipeline with an additional out. So you see the power is really, that the world is you get full transparency and capabilities to work with whatever data you have in your Oracle database through a document store driven API. Okay. Some of the other things that I want to quickly touch on, I said one of the things it's also to bridging the gap, right? That's a 23C environment. So I could use the index creation from within the Mongo framework, but I want to do here is I'm just wanna quickly do the index creation through the SQL pass-through, which is what you would have to do in 19C. In case you wonder about the weird index names, you can generate the indexes based on the information about an existing Mongo schema. So we have code for that, PL SQL code for that on GitHub. If you're interested, we can share that with you, which actually goes through your collections, the existing Mongo indexes, and creates the Oracle appropriate syntax for it. For the sake of time is already used. Okay, see, this happens when you're actually playing around with environments. Let's just see that I'm just dropping the indexes, and now we should be able to create them again. Oops, did it just do the first one? No, I'm not that familiar with the, okay, specified index does not exist. It only dropped the first one. So now this is the Mongo plugin, right? And I'm still learning as I'm pressing buttons here, but now it went through. And now let's create the second index. So it seems not be capable to execute multiple statements in once. So I created 2 indexes, and if you wanted to see whether these indexes actually make a difference, we could, so this is just finding the movies for a specific year where I created an index on. Oops, select one or more lines. Okay, so well, you see I'm getting results, but that is not the interesting thing. The interesting thing is actually if I want to see what does the execution plan look like for that. And here we go. Let me just, where's the line? I'm always. So you will see here the columns that were attached, and there was an index range scan on the Aura movies index that we just created a second ago. Okay, last but not least, there was one question that I was actually expecting on the Q&A, but I didn't get it, so I'm just answering it anyways and asking it myself. So one of the questions that we got with people that we talked to when we actually developed and introduced this functionality was okay, what's the security framework of what we're doing here? What we're doing, the Oracle database API for Mongo has a different authorization and authentication scheme than a Mongo database. We consciously decided to integrate this into the overall security framework of Oracle, meaning that when you connect to a Oracle database with a user, right, the user is mapped to a schema. So when you see here, the database JSON, that is equivalent to the schema JSON/user JSON in the Oracle database. So depending on what this user is allowed to do in the database, that drives what you can actually do with the SQL pass-through, right? And that's just a user that has development privileges. So if I'm trying something like that, or actually let's just do that quickly in the Mongo shell. Probably let's just show the Mongo shell so you connect to that. If I'm doing this statement here, you will see that you get a nice and friendly Oracle error message passed through, which tells you table of view does not exist, which is equivalent to you're not allowed to do this in the Oracle world. So you get exactly the same behavior as what you would get here with the same statement, right? If you do a select star from DBA users. Okay, looking at the clock, I think I'm almost talking too much. So let's probably go back to the slides and wrap up and have some time for additional Q&A. So again, so the SQL integration that we do here is really, we integrated in this aggregation pipeline stage $SQL to really allow transparent execution of user-defined SQL to being able to enrich what you're dealing with in the document world and to pass data to and from MongoDB applications coming out of the Oracle ecosystem. When it comes to support, and there were 1 or 2 questions on the chat, what I've shown you is available today in the Autonomous Database 19c. It will be, and it's imminent as soon as ORTS 24 is released. And actually, when we prepared the slides, we were expecting it to be out. So it's really almost close to a hold your breath kind of state. Although, don't hold your breath. I don't know how long you can hold it. It's probably not within the next 2 or 3 minutes. Then it will be available for not only the Autonomous Database serverless, where it works today with the limitations of an Oracle Database 19c, but also for any unmanaged, what I call the unmanaged Oracle database, where you're in control and manage the database, whether this is on premises or in the cloud, it will be there, right? In 19c, the limitation is that $SQL is predominantly a single stage operator with some limited support of some of the aggregation pipeline operators. That's the details here on the doc, just to point out some that work is match, skip, limit, project count, and obviously with the Oracle database 23. So I was using a 23.3 database running in the Oracle Cloud that I used for the demo, where we have $SQL as an integrated operator into the Oracle support of the aggregation pipeline framework overall. So what you have seen here is a production database with a slightly patched orts, slightly ahead of you guys, that I used for that demonstration, right? And the idea here is really, the thing is what we started with, the theme of the MongoDB API was really to support you for any workload with any kind of data type, with any kind of requirement that comes from your application, in the most integrated and simple work to really reduce your cost and risk, right? It's, if you do things like that, right, you store, use, and manage all your data, relational data, JSON documents, go down the path of spatial graph or whatever you're thinking of. AI, right? I haven't used the buzzword of the day, AI, vector, all within the same environment in a unified, converged database with a single management, security, and consistency model. And we give you the flexibility to use whatever API you want or language you want to use to work with your database, right? So I'm used the VS Code plugin and briefly the Mongo shell. I could have used, the Python SDK or any other framework with the MongoDB API to show you the same. Okay, you will get the slides later on. There's a couple of pointers that give you more information about the autonomous JSON database, what we do with the MongoDB API. We have some existing live labs that we are just about to update to reflect this new functionality. Unlike you for the live labs, for the 23C live lab, we wait for the 24 orgs to do that, but there's a lot of pointers for you to get started imminently. And with that said, thank you for sticking around with us. And if there's any further questions at that point in time, open questions from you. Beta, Josh, do we have anything on the channel, or did you?
No, we answered all the questions. There's one new coming on how does licensing work. I don't think there's any extra licensing needed for any of this, right? So if people have Oracle, Orts has this footsie license, right? Which is free for everything.
When you have Oracle, you have the rights on Orts, right? You can use that. And what we have seen here, so it's free of charge. The MongoDB API is free of charge, and the functionality that you pass through is it's all part of the database, right?
There was one question I answered, and this was, I think, like a clarification on the question was, hey, we had JSON in the database. How is this different? And this is really just augmenting. So it exposes JSON support in Oracle database through the MongoDB API. So we have a lot of interfaces or APIs, like SQL is one, REST is one. We have SODA for simple Oracle document access, where we have various language drivers, let's say for C or Node or Python. But we came to realize that many developers want to use MongoDB drivers or MongoDB tools, MongoDB frameworks. So this is why we provided this compatible API. But under the covers, it's really Oracle or JSON support in Oracle. So a Mongo command gets translated to an equivalent SQL command. So this is how it works in general. And with this extension here, I think this is really the great capability that we're adding. If you have a developer that prefers to work with MongoDB's tools because they have some skills in that area, or they just think it's simpler, it's very easy to for them to continue working that way with Oracle. But now, and this is for the first time, they really have very easy access to even relational structures. Like if there's existing systems which are written 10 years ago, 20 years ago, everything is relational, there's no JSON. Now it's very easy to even access that data through the MongoDB API. And again, if you store it once in Oracle database, you don't have to move data around, and therefore data cannot get stale or inconsistent, whatever. So it really simplifies the operational aspect of things. There's another question on the document sizing. I think Josh is typing.
Yeah.
The size limit is 32 megabyte, which is 2 times MongoDB's
compressed
limit
size,
is, right?
right?
Yeah.
That's compressed size. And
Yeah, compressed, right? Yeah.
yeah. Cool. I just saw something like I will email you flying by with one eye and the other.
Yeah, I mean, actually, that's a good comment. So
Please
we will.
contact us, right? If you have any questions, follow-ups, if you want us to look closer into
Hey, how do
what.
they contact us? What's the contact information?
Actually, I had planned to put our emails on the slides, but silly me, I kind of forgot. But
Okay,
it's
perfect.
very
Yeah.
simple, right? Let's just quickly do it, right? The way of how our emails work is brain dead, right? So betas would be okay.
So just like a dot between the
It's
first name and the
basically
last
exactly.
name.
My name is okay. I put my
You
umlaut
got
in.
the umlaut there, right? So
Okay, so would be okay. This
exactly.
way I guarantee that Josh gets the first email.
He gets it.
Okay, so this is how it would be for him. And for the odd duck here, back to the world of 7 bits.
ASCII, yeah, you only got.
Yes, 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 yes. Don't even talk UTF, right? So it's that, right? So you can get in touch with us at any point in time to discuss it. Cool.
Yeah. And we would be more than happy to demonstrate this to if you have like a development team that's
Yes,
interested, we can
yes,
also do like individual presentations or
absolutely. Absolutely.
help you with your projects. Cool. Thanks a
Cool.
lot.
With that said, thank you. And I think we're
Just on time. Yeah, perfect.
fantastic, right?
Okay.
We should get a coffee just for that. Okay. Thank you, folks.
Okay. Bye.